Hello and welcome to another Callum Cymru. Again, I'm going to be looking at statistics and this time it is A2 probability. So if we go on to the next slide, probability, understand use conditional probability, including tree diagrams, Venn and two-way tables. Understand and use conditional probability formula. So the probability of B given A, they've sort of written it slightly differently there, but it is the probability of B given A equals the probability of A and B over the probability of A. So if we start it, and as I said, the way I would probably write it is the probability of A given B is equal to the probability of A and B over the probability of B. Now, I'd like to sort of restart from probability at AS level, which was all of these formulas that we'd written down. We talked about whether things were mutually exclusive, what that looked like, the two sort of independent formulas, how you could determine whether events were independent or not, which is A and B is A times B, and then A or B is A plus probability of B minus the probability of A and B. So you can use those two to find if they're independency. Mutually exclusive, how it would look on a Venn diagram is you would have a circle here and a circle here. There would be no overlapping whatsoever for mutually exclusive, and probability of A or B is equal to the probability of A plus probability of B, effectively the and or rule. Probability of A is 1 minus probability of not A. A dash is not A. Probability of A is equal to the probability of A and B plus the probability of A and not B. And then finally, the probability of A and B equals the probability of B and A. Those are the formulas that we wrote down for AS. And as I say, for these type of questions, I would highly recommend having them. So the extra one that I'm going to put in, which is what I had put on the previous slide, which is the probability of A given B, so this is the conditional probability, is the probability of A and B over the probability of B. And as it had rearranged in the other one, because the probability, this one down here of A and B is equal to B and A, we can also write down the probability of A given B times the probability of B is equal to, and then we could put it as the other way around, which is the probability of B given A times the probability of A. They're just nice formulas to have, so when you try sort of new questions, you can then see whether or not they link in. Sometimes you don't need the formulas. If it is a tree diagram or a Venn diagram or even a two-way table, you can just take the numbers directly from the diagram and put them into a fraction. Other times you're going to have to need, especially if you're sort of testing for independence, you're going to have to be using them. For the next slides, what I've basically got as examples, so we have tree diagrams, Venn diagrams, and two-way tables. I've put in a geometric question because they like to put them in there, so I thought I'll put one in here. And I've also put a sort of a problem solving in terms of pure, where it would lead to a quadratic. That being said, if we get started. So, first question is, it is known that 4% of a population suffer from a certain disease. When a diagnostic test is applied to a person with disease, it gives a positive response with the probability of 0.98. When the test is applied to a person who does not have the disease, it gives a positive response with a probability of 0.01. So it's basically saying you're having a false positive. Using a tree diagram or otherwise, show the probability of a person who does not have the disease given a negative response is 0.9504. So if we were to sort of draw this tree diagram for part A, so part A is here, you've got the disease, you haven't got the disease. The probability that the overall population is 4%, so that's 0.04. So then this is 0.96 because it has to add up to 1. The probability of being positive having got the disease is 0.98. So here we have a false negative, so this would be 0.02. And then positive, even though you haven't got the disease, is 0.01. And then this is 0.99. So it's asked, so there's your sort of tree diagram for the 2 marks, but it's also asked you to make sure that you've understood what you've done. What's the person who does not have the disease? So the probability that you don't have the disease and does not give and a negative response. So it is 0.96 times 0.99, which gives us our answer of 0.9504 for part A. For part B, it then says the test is applied to a randomly selected member of a population. Find the probability that a positive response is obtained. Well, you can have 2 different positive response. You could be with the disease and positive, without the disease positive. So it's again probability that you have the disease and positive, or, which I'm going to put as plus, the probability that you don't have the disease and positive. So it would be 0.04 times 0.98 plus, and then 0.96 times 0.01, which would give a total of 0.0488. So that is the probability of being positive. And then part C, so we've done A, B, and C, using just plucking the ideas or the values from the diagram. So C, given that there is a positive response is obtained, find the probability that the person has the disease. So probability of disease given positive. So it's the probability of disease and positive over the probability of positive. Well, we've just worked out the probability of being positive as 0.0488. And now we need to work out what the probability is having the disease and being positive. So this is going to be the top end of the tree. So it's going to be 0.04 times 0.98. And that gives us an answer of 0.803. And there you're using your tree diagram. You don't have to use the tree diagram, although it does help to visualize exactly where you're getting all the numbers from. For the next question, it is again, I'm not going to sort of do a tree diagram, but it's the sort of element. It's a 6-mark question, so there's lots of things going on. So it'd be interesting to see how you would sort of cope with these type of questions. And what I would suggest you doing is, if you want to pause and try the question yourself, and then after you've sort of tried it, you can then sort of restart it. As with all of the sort of Callum Cymru videos, it is useful to do that for revision. So we have 12 balls, 5 red. I always like to put down here how many I've got of each. So I've got 5 red, I've got 4 blue, and I have 3 white. A random selection of 3 balls is made without replacement. That statement there is very important. Calculate the probability that selection contains 2 balls of the same color and another ball of a different color. Give your answer in that form. Well, the calculator is going to put it in a form we then need to sort of put in. So if we start with the red, if we've got 2 red balls, then the third must not be red. I'm not going to go waste my time and go red, red, blue, or red, red, white. Is not red instead. And that, so if we would say the probability of red, red, and not red, sorry, let me just get rid of that. That can be written down 3 different ways. Red, red, not red, red, not red, red, not red, red, red. So I'm just going to times that by 3. Plus the probability, and it's going to be exactly the same for blue. So it's blue, blue, not blue, and again can be written 3 times, plus the probability of white, white, and not white. I should have put these in here instead of sort of commas to show that it is going to be times. So and there we go, and so we just need to remember there's not been replaced. There are 12 balls in total. So for red is going to be 5 over 12 times 4 over 11 times, and then the last one is going to be 7 over 10. And that's going to be multiplied by 3. Plus for blue, it is going to be 4 over 12 times 3 over 11 times 6, 7, 8 over 10. And that is times by 3. And then for white is going to be 3 over 12 times 2 over 11 times 9 over 10. And all of that is multiplied by 3. And again, you can easily put that into your calculator. It would come with 870 over 1320, which simplifies to 29 over 44. And the fact that you've got a 44 on the bottom, which is asking for n where n is an integer, means that you must have done it correctly, or the more likelihood is that you've done it correctly for this to sort of move on. Next question. Here we have sort of more of a formula-based question. So I can remember what the formulas are. I've got them in a sheet, as it would be best if you'd written them down, and you've got them in a sheet in front of you. So then you just pluck in the ones that you require, and then you're using them as you're doing it. Here we have the events A and B. Probability of A is 0.3, probability of B is 0.2. We don't know what A and B are, and to be honest, for the purpose of this question, we don't really care. We just need to sort of calculate. Given that the probability of A or B is equal to 0.44, show that A and B are independent of each other. So the two formulas that we're going to use for part A, the probability of A and B is equal to the probability of A times the probability of B. So that's 0.3 times 0.2, which is 0.06. The other formula is probability A or B, and then so on and so forth. I'm just going to rearrange it straight away. A and B is the probability of A plus the probability of B minus the probability of A or B. Most of the time you see it, these two are sort of interchangeable with each other, but for the purposes of this, I'm just going to write it like that. So it is 0.3 plus 0.2 minus 0.44, which also gives you 0.06. Therefore, they're independent because both formulas match. Now, be careful with the next part because it says for part B, given that the probability of A or B is equal to 0.4, calculate. So B part 1, if I put a line down here, then I can do part 2 over the other side. So given the probability of A given B is that. So we would then write down our formula. A given B is equal to the probability of A and B over the probability of B. At this moment in time, I don't have the probability of A and B. I need to calculate that. And again, I would use this formula up the top here, where it is the probability of A and B is equal to 0.3 plus 0.2 minus 0.4 in this case, so it is 0.1. So we have 0.1 for the top, probability of B is 0.2, so this gives me 0.5. Just be careful, sometimes halfway through a question, they will change exactly what they're trying to sort of do, or change the direction in terms of things that you need to be aware of. And then for part 2, so part 2 says, what is the probability of A given not B? Sorry, I've got all my calculations on my sheet. There you go. So again, I would start with a formula. The probability of A given not B is the probability of A and not B over the probability of not B. Well, the first bottom one we can easily do. So the probability of not B is 1 minus the probability of B. And since B is 0.2, this is going to give us 0.8. I'll make sure there's room for that there. Next, we need to do the probability of A and not B. Well, if you look at the sort of, again, the formula, I have said that the probability of A is the probability of A and B plus the probability of A and not B. And again, if you were to sort of draw a Venn diagram, probability of A and B would be the middle section, and then the probability of A and not B would be the other sort of moon element, and that gives you the whole circle of probability of A. So we know the probability of A is 0.3. We've worked out the probability of A and B is 0.1. And then plus this, well, the only thing that's going to work is 0.2. So this is now equal to 0.2. So we would write this as 0.2 over 0.8, which is 0.25. Again, I like this question because it's bringing in all of the formulas. It has a more of a pure feel to it rather than a statistics. And then you're picking them up and you're sort of putting in the information that you know, and then you're rearranging them and going from there. On to the next question. Okay, so this is what I'd call a two-way table. I've put this in and I've put a couple of Venn diagrams in. I'm basically trying to give you as much of a diet of everything so that you can sort of see where it all comes from. The first thing I would do with a two-way table is to add up these. So this is 56. This is 144. So Deirdre is the head teacher in a school which provides primary, secondary and sixth form education. There are 200 teachers in a school, which is 5644 adds up to 200. The number of teachers in each level of education along with their gender is shown in the table below. So there are 56 male teachers, there are 144 female teachers. A teacher is selected at random. Find the probability the teacher is female. Well, it's a nice straightforward one to start with. That's going to be 144 because there are 144 female teachers over 200. I'm quite happy for you not to simplify. Okay, the teacher is not a sixth form. I should have added these as we're going along. So that is 47. That's easy if I don't do that. So then the teacher is not in the sixth form, so it's going to be 1 minus 47 over 200, which would then be 153 over 200. Therefore, excuse me, I'm assuming you add these, what's that, 109? And 35 is going to be 44. So then when we add these, that would give you 153 over the 200. Okay, then there's that word given again. That a randomly chosen teacher is male. Find the probability that this teacher is not a primary school teacher. Well, if we have a look at the male teachers, there are 56 of them. So that's going to be on the bottom. And if it's not a primary school teacher, it is going to be the secondary plus the sixth form. So then that is going to be 47 over 56. And then the last question, Deirdre wants to select 3 different teachers at random to be part of a school project. Calculate the probability all 3 chosen are secondary school teachers. So secondary is 109. So it would be 109 over 200 times 108 over 199, because it's not going to be replaced. You're not going to pick the same 3 people, times 107 over 198, which gives you an answer of 0.16. And that's how I would, as I say, pluck the information from the two-way table and then just pick it in as and when you want to put it in for the different places. Next question. Here we have a Venn diagram, and I thought this one would be quite nice because of the fact that you are taking the information from the table above and then putting it in, as well as sort of having questions such as independence and everything else. Okay, so a sample of 240 households were asked which, if any, of the following animals they own as pets. So you have cats, dogs, and tortoises. The results are shown in the table below. So we have cats, 153, so on and so on. So you can read the information yourself. With a Venn diagram like this, I would start with the center and then work your way out. So cats, dogs, and tortoises is 17. So there are 17 people who own all three. So we would put 17 in the middle. Now remember, this circle of cats here would add up to 153. So we also need to work out that there are 30, where we cats and dogs are 48, so 48 minus the 17, because they have been taken care of, is going to give us 31. And then we want cats and tortoises, 21 minus the 17 is going to give you 4. And then again, you do the same with dogs and tortoises, 32 minus the 17 is going to give you 15. And tortoises in total is 45. If I add up the 17, the 15, the 4, and take it away from the 45, I'd get an answer of 9. And then for dogs, which has to be 70, add up 31, 17, and 15, and take it away from the 70, that would give me 7. And if I then add up each one of these values together and take it away from 240, I would get 56. So interpreting, there are 56 that don't own any of these three pets. There are 17 that own all three, so on and so on. So you can easily then see where all the information is. Now, as I say, you can either use the Venn diagram, or there is other ways in which you can work these out. I will just use the values from the Venn diagram, because we've just gone to that trouble, and that's the way they want you to answer it. A household is chosen at random from the sample. Find the probability the household owns a cat only. Well, there are 240 households, so I know that that is going to be, so the probability of cat, actually let me put cat only so it doesn't mislead. Well, 101 over 240. Next, the probability that a household owns at least 2 of the 3 types of pet. Let's see, is that highlighted? So 2 out of the 3, you've got that one, that one, that one, and that one. And those values would be, say, over 100 and, 240. So it's going to be 4 plus 31 plus 17 plus 15, and that is over 240, and that would give you 67. Find the probability that a household owns a cat or a dog or both, given that the household does not own a tortoise. So if it doesn't own a tortoise, then it is not one of, that's too dark. No, that'll do. It is not one of these, because they are in the tortoise sort of section. So if we were to remove 9, 15, 17, and 4, we would get an answer of 195. And then we would add up 101, 31, and 7 to give us an answer of 139. Then determine whether a household owning a cat and a household owning a tortoise are dependent of each other. So the probability of cat times the probability of tortoise. So if we were to add up all of the cats, well, it's 153. So it's going to be 153 over 240 times, and then tortoise is 45 over 240, and that equals 0.12. Then if we look at the Venn diagram, it is going to be, again, it's 240 on the bottom, but it is going to be 4 plus 17, which is 21 over 240, which is approximately 0.08. Let's put the point in the right place. It's not approximately, it's exactly 0.0875. Therefore, they are not independent. I hope you followed everywhere where we were sort of coming from with that, and picked up all of the numbers. The next question, again, it is formula based. So question 9, and it's asking halfway through for part C if you could draw the Venn diagram. So if I was to put the Venn diagram on this side, let's do part A here. So part A, work out the probability of not A and not B. Well, the probability of not A given, not B, is the probability of not A and not B over the probability of not B. And again, we can easily work out the probability of not B is equal to 0.55, because it is just, if I put it here, probability of not B, 1 minus this, so it's 0.55. We now need to work out the probability of not A and not B. Again, if we were to look at a Venn diagram, it would be the space everywhere outside of that. So that would be 1 minus the probability of not A or B. So it would be probability of not A and not B is 1 minus the probability of A or B. And this I can work out. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B, which is 0.35 plus 0.45 minus 0.13, which is 0.67. So then this is equal to 1 minus 0.67, which is 0.33. So we have 0.33 divided by 0.55, which is 0.6. Explain why A and B are not independent. Well, if they were independent, we would have that the probability of, I'm going to put this here, probability of A times the probability of B, which is 0.35 times 0.45 equals 0.1575. And this does not equal 0.13, so not independent. Hope you're following. Part C is, we're told that event C, probability C is 0.2. The events A and C are mutually exclusive, and the events B and C are statistically independent. So A and C are mutually exclusive. So like I said at the beginning, they're not going to have any crossover points. And you're also told that B and C are independent. So if we were to draw our Venn diagram, which is asked to draw a Venn diagram to illustrate, we are going to have B, which is going to overlap both of them. There's B. here now is A, and I can fill in from the information. So this is going to be 0.13. 0.13 take away 0.35 is 0.22. I'm not going to put in for B yet. And then obviously this goes in here. If the probability of A and B, sorry, probability of B and C is the probability of probability of B times the probability of C, which is 0.45 times 0.2, 0.09. So this is 0.09. This is going to be 0.2 take away that, so it's 0.11. And then I'm going to have to add 0.13 plus 0.09, which is 0.22, and then take that away from 45, leaving me with 0.23. Adding each one of these values together and taking away from 1 is going to give me 0.22. So on the outside, I got 0.22. For A on its own is 0.22. The whole thing for A is 0.35, so on and so forth. Then it says for part D, find the probability of B or C dash. So it's not B and C. Well, if we would just pluck the information, it's going to be 0.22 plus 0.22, this part from just A, this part from everything taken away, is equal to 0.44. Next slide. We've got a couple left. As I said, I've tried to put in different elements of probability so that you can see where and how, what types of questions you could ask. So we have Mary and Jeff are archers, and one morning they play the following game. They shoot an arrow at a target alternatively, starting with Mary. The winner is the first to hit the target. You may assume that with each shot, Mary has a probability of 0.25 of hitting the target, and Jeff has a probability P of hitting the target. Successive shots are independent. Determine the probability Jeff wins the game on his first throw. So for part A, 1, you've got Mary and Jeff. Mary's going to miss, Jeff's going to hit for the first throw. So then that is going to be the probability that Mary misses is going to be 0.75, and then Jeff hitting is P. Part 2, with the probability of a second throw. So Mary misses, Jeff misses, Mary misses, Jeff hits. So then that is going to be 0.75 times 1 minus P times 0.75 times P. If I tidy that up, I'm not going to expand it because I want it to be kept so that you can see what's been added to it each time. That would be 0.75 squared, 1 minus P, and then you would have P. Show that the probability Jeff wins the game is, and then you have got that. Now, what I'm hoping you would see with this type of question is it is just a geometric, okay? And because the probability is between 0 and 1, you're going to use the sum to infinity of a geometric distribution. So if we think of the first term is 0.75p, so that's him winning on his first. If he was to win on his second, it's going to be 0.75 squared 1 minus p. If he was to go and win on his third, it's going to be 0.75 cubed 1 minus p squared p. It's going to be then added each bit every time. Then to sort of work this out, we're going to use, for a geometric, sum to infinity of a over 1 minus r. Our a is the first term at 0.75p. Our common ratio r, well, what have we added each time? We've added a 0.75 and we've added a 1 minus p to it. So if we were then to substitute this in, it is going to be 0.75p 1 minus 0.75 1 minus p. Simplified down, 0.75p on top, 0.25, because it would be 1 minus the 0.75 is 0.25, and then it is this minus and minus makes it a plus, so then that would be 0.75p. If I multiply both of these top and bottom by 4, then because this is 3/4 p times by 4 is going to be 3p. This is 1/4 times 4, so it's going to be 1. And then this is 3/4 again times 4, so that would be plus 3p, which would give me the formula that we have then got. The next question, so look out for this one, especially they could be 2 or even 3 sort of players, and then they'll give the starting person, and it would be alternatively, and it will be in that order. So Mary, then Jeff, or if it was a third player, then you'd go from there. But type out the first one, first chance of winning, the second chance of winning, and it's always useful to put that third chance down, and you can show that it is a geometric sequence. Question 11. So again, you have seen this, and it might be interesting to do as a sort of a tree diagram. So Maria is an athlete who competes in the high jump. In a certain competition, she is allowed 2 attempts to clear each height. But if she is successful with the first attempt, she does not jump again at this height. The probability she is successful with the first jump at a height of 1.7 is p. The probability she's successful with a second jump is also p. Find the probability, the probability she clears 1.7 meters is 0.64. Find the value of p. So again, if we put a sort of a tree diagram, probability is p. 1 minus p, she fails. She's not going to jump again if she's sort of passed. So she would go again, and then this would be 1 minus p. There's your sort of a tree diagram with it. In terms of, if she gets it on the first attempt, it's p, she stops. If she doesn't get it with the first attempt, then it is a failure, then it is success, and that is overall 0.64. Expand this, it is p plus, what have we got? P minus p squared equals 0.64. Take it over to the other side, you have p squared minus 2p plus 0.64 equals 0. It's not acceptable to just put this in the calculator to solve it. You must show a method. There's nothing wrong with factorizing. If you're not happy with factorizing the decimals, you could obviously times it by 100. It's going to make it more complicated, or what would be easier is to put it into the quadratic formula. I did factorize it because it was going to be 0.4 and p minus 1.6 equals 0. P is equal to 0.4 or P is equal to 1.6. We can't have 1.6, so the P is equal to 0.4. The reason why we can't have 1.6, and I would expect to see this, otherwise that would be losing 1 mark, is because of the fact it's greater than 1. You could make your own questions of that, changing the probability and everything else. And the last one, here we go. So this is similar to the first question that I've done, where it says a disease that affects trees shows no visible evidence for the first few years after the tree is infected. A test has been developed to determine whether a particular tree has the disease. The positive result to the test suggests that the tree has the disease. However, the test is not 100% reliable, and a researcher uses the following model. If the tree has the disease, the probability of a positive result is 0.95. If the tree does not have the disease, then the probability of a positive result is 0.1. It is known that a certain county, 35 county in A, 35% of the trees have the disease. A tree in county A is chosen at random and is tested. Given that the result is positive, determine the probability that the tree has the disease. So for part A, probability, disease if positive, is the probability of disease and P over the probability of P. Now, if you can either sketch the tree diagram that would help with this, or you can, as you said, sort of see it in your mind's eye. So diseased and positive. Well, it is known that a certain type, so it's 35%. So it's going to be 0.35 multiplied by being testing positive, which is 0.95, over testing positive in total is going to be 0.35 times 0.95 plus, and then 0.65 times 0.1, which is a simple sort of values you can put in the calculator and comes out as 0.836. Part B, a forestry company wants to determine what proportion of trees in another county, B, have the disease. They chose a large random sample of trees in county B. Each tree in the sample is tested. It is found that the result is positive for 43% of these trees. By carrying out a calculation, determine an estimate of the proportion of trees in county B that have the disease. So if we say let the proportion having disease, so having disease is equal to P, just to make our life easier. So it says, what we got, each sample is tested and it's found the result is positive for 43%. Well, if you're positive 43%, you're going to have 0.95p plus 1 minus p times 0.1, and that is equal to 0.43. So this is testing positive and sort of being positive and testing, which is 0.95 times p. This is being negative, so it's 1 minus p, and testing positive, which is 0.1, because the overall test of these trees being positive is 43%, so it's 0.43. From this, we would have 0.95 minus 0.1p, so it is going to be 0.85p, and then this is going to be plus 0.1 equals 0.43. Rearranging, so it's 0.85p is equal to 0.33, taking the 0.1 over, and then having the probability of the sort of trees in county B having the disease is going to be 0.33 divided by 0.85, which gives a value of 0.388. So we can say that 39% of the trees in county B have the disease. I hope you found this video helpful, and if you are sort of going through some of these questions, you can pause them, try them yourself, and then work through or play them so you can see the end results. If there are other sort of subjects that you are learning or that you're sort of going to be revising for, then you can sort of pop along to the Callum Cymru website, which is shown below, and then there are several videos that you can sort of see, either in maths or sort of various other subjects. Thank you for your time. Goodbye.